Welcome back, AP Statistics. This is Chapter 19, Testing Hypotheses About Proportions. So let's talk about what the purpose of something called a hypothesis test is. Hypothesis tests and confidence intervals are two aspects of a broader statistical topic called inference. So when we talk about statistical inference, we're referring to confidence intervals, which we've already discussed, and hypothesis tests. So let's get into it. Suppose a company tries to increase sales by running an ad campaign. If the sales go up, how can the company know if either the ad campaign is what's behind the increase in sales, or the increase in sales is not significant enough to be attributed to a successful ad campaign? Statisticians used a process called hypothesis testing to answer questions like these. If there is a difference in how the company is doing because of the ad campaign, is it significant enough, or is it just an increase in sales that's kind of due to chance? And maybe next time we look at the books, the sales will go down a little bit. Is it just an incidental change, or is there a real big change that we should be keeping an eye on? Maybe the ad campaign is working. So we need to talk about the null and alternative hypotheses. To determine whether our ad campaign was actually behind the increase in sales, we must consider two possible hypotheses. First is H sub 0, H subscript 0, which we call the null hypothesis. That means nothing significant has changed. Sales might have gone up, but not by enough to be deemed more than mere coincidence. The alternative is just that, the alternative hypothesis, all right? So the alternative hypothesis is that there is a significant change, and that the increase in sales is likely not a fluke and is likely due to successful ad campaign. Notice we can't determine definitively whether there is a significant change due to the ad campaign or that there's a guaranteed cause and effect. But we can show that there is a significant change, and the change is likely not a fluke, and that it's likely due to a successful ad campaign. One note here, just to make sure I don't miss this, under null hypothesis, we have this detail here. We assume the null hypothesis is true going into the test. Think about innocent until proven guilty, all right? The ad campaign is innocent of producing a significant difference in the sales until it is proven guilty, all right? We side with the null hypothesis. Nothing significant has changed unless we have enough evidence to reject the null hypothesis and support the alternative hypothesis. And that's important. I'll say it once, I'll say it many times. You can never support a null hypothesis, all right? The null hypothesis can either be rejected or not rejected. You cannot say a null hypothesis is definitively true. However, it is what we assume unless there is evidence to the contrary, but you cannot support or affirm a null hypothesis. It's either rejected, if we should side with the alternative hypothesis that there is a significant change, or it's not rejected. We don't have enough evidence to reject it, okay? So we only assume this hypothesis is true, the alternative that is, if we have enough evidence to reject the null hypothesis. Okay, so we assume the null hypothesis is true. We cannot confirm, but we assume innocent, no significant difference, until proven guilty of a significant difference. Let's look at an example. Suppose our headmaster, Mr. Clymer, proposed that the proportion of FCA students wearing faith gear on a given day is an even 50%. Were Mr. Clymer's claim to be tested, the hypotheses would look like this. Null hypothesis. Proportion equals 0.5. And notice this is not a sample proportion. This is a population proportion. That means, null hypothesis, there is not a significant difference between the true proportion of students who wear faith gear and Mr. Clymer's prediction. The alternative is that there is a significant difference between the true proportion of students who wear faith gear and Mr. Clymer's prediction. Okay, Mr. Clymer makes his prediction. We assume that there's no significant difference until we can prove significant difference. Innocent until proven guilty. Now we're going to suppose that Mr. Clymer proposed ever since FCA set up a school store a couple years back, we did. The proportion of students who wear FCA gear on a given day is above 50%. Were Mr. Clymer's claim to be tested, the hypotheses would look like this, right? The null hypothesis is the proportion equals 50%. The proportion of students wearing FCA is not significantly above 50%. And notice we don't say if not significantly above, that means less than or equal to. We just say equal to. Old school statisticians would use a less than or equal to sign. However, more recent years, we just say equals. The alternative is the proportion is significantly above 50%, or that the population proportion is greater than 0.5. Now let's look at another example. Summit Projects was a full-service interactive agency based in Hood River, Oregon, that offered companies a variety of website services. One of Summit's clients, Smart Wool, produces and sells wool apparel, including the famous Smart Wool socks. Pictured to the bottom right, this is not an endorsement, it is merely an example. After Summit redesigned Smart Wool's apparel website, analysts at Smart Wool wondered whether traffic had changed since the new website went live. That's an interesting way of writing the word website. Moving on. In particular, an analyst might want to know if the proportion of visits resulting in sale has increased, decreased, or stayed pretty much the same since the new site went online. She might also wonder if the average sale amount has changed. If the old site's proportion was 15%, what are appropriate null and alternative hypotheses for the proportion? Okay, so think about what the null and alternative hypotheses might look like. The null is pretty straightforward. The alternative might take a little thought. All right, I'll assume we're ready to continue. Here we go. We're going to let P be the proportion of visits that result in a sale. So we've defined our variable, our parameter P, the population proportion of visits that result in sale. Then the null hypothesis is P equals 15%. That is the old site's proportion of visits that result in sale. The alternative hypothesis would be that there is some kind of change from 15%, that the switch from the old site to the new site produced a proportion that's either much better or not as good, but significantly different in some way, shape, or form. Going on with the theme of legal language, like innocent until proven guilty, it's helpful to look at a hypothesis test like a trial in court. Okay, so here is a layout of what happens in a trial in court, or at least what should happen in a trial in court. And the textbook uses this magnificently as an analogy, so I am admittedly borrowing this directly from them, as I do many resources in this course. So let's consider a court trial. There are two possible verdicts, innocent or guilty. We assume the defendant is innocent until proven guilty. The law defines what evidence would constitute a guilty sentence. Evidence is then put forth. If the evidence matches the law's description of the crime, we reject the assumption of innocence and conclude guilt. Otherwise, we continue to assume innocence. Closing remarks are made. Now let's apply this same line of thinking to a hypothesis test. A hypothesis test is like a trial. There are two possible verdicts, the null hypothesis and the alternative hypothesis. We assume the null hypothesis is true. We determine what constitutes a significantly different outcome than we would expect, what is outlined in the null hypothesis. For example, if Mr. Clymer proposed more than 50% of students wear FCA gear and it turns out that today 52% of students do, then perhaps Mr. Clymer made too big of a claim. The difference between the proposed proportion and our collected data is not significant. However, if a whopping 65% of students wear FCA gear today, then Mr. Clymer is probably correct. The difference between the proposed proportion and our collected data is significant, right? So that word significant is important. There needs to be some kind of threshold. What is the threshold? That is what we will address in the remainder of this chapter. So we gather data. Then we determine if we have enough evidence to reject the null hypothesis and support the alternative hypothesis. Okay? Is there enough evidence to show that the significance is so great that we reject the null hypothesis and support the alternative? Or is the difference not very big and we would say, well, we do not have enough evidence to reject the null hypothesis? That's not saying the null hypothesis is true. We can never ever confirm a null hypothesis, and we'll talk about why that is later in the section. We're only trying to determine if we have enough evidence to reject it. So if there is no significant difference, if there is a difference but it's quite small, we would say we don't have enough evidence to reject the null hypothesis. Or if there's a big difference, we would say we do have enough evidence to reject it. The null hypothesis exists to be either rejected or not rejected. We can never accept it as fact. That actually sounds kind of sad. Moving on. We summarize our results in the context of the study we are conducting. Just like in a court case, we end with closing remarks. We need to summarize the results we find in the context of the study we are conducting.